Right, hi there. These are some example problems on how to do oxidation numbers or to determine the oxidation number of an atom inside of a compound. You had a bunch of rules that you needed to look at, and most of these problems are solvable using three basic rules. Oxygen's almost always minus 2. In most of the compounds that we look at, oxygen's minus 2. We need to know that the sum of all oxidation numbers adds up either to the ion charge, if we're looking at a polyatomic ion, or to the compound charge of 0. So either ion charge or the compound has to add up to 0. So those are the three rules that we use most often. Let's see how those work in action. So the perchlorate anion, we can see that it's a -1 charge. And you can solve it kind of like this. We know that this needs to equal -1. Each oxygen is -2, and there's 4 of them, so that's equal to -8. And then chlorine is the number that we don't know yet, so that's x. So if this is just a simple algebraic expression, add 8, x is equal to +7. And if you try that, +7 minus 8 equals -1. That's exactly what we'd expect. The chlorate anion, on the other hand, is equal to -1. We have 3 copies of -2, so that's -6. X plus -6, add 6, x equals +5. One thing that's worth noting is for the oxyanion series, like the perchlorate, chlorate, chlorite, hypochlorite, the anion that the oxyanion is named after is always going to take the predicted metal charge for the topmost oxyanion. So for example, perchlorate or nitrate, perchlorate, the chlorine takes the +7 charge, nitrate would take the, nitrogen would take the +5 charge. In this example here, here's a binary example. So this whole thing needs to equal to 0. So set it equal to 0. 3 times -2 is -6. X plus -6. So x equals +6. There's your number. So sulfur's charge would be a +6 in this compound. The P in phosphoric acid. So you can solve this in one of two ways. We know that this is a compound and the whole thing needs to equal 0, or you can see that there's an anion here that you should be familiar with, the polyatomic anion phosphate, which is equal to -3. So you could solve it in either way. Hydrogen's going to be +1 because it's in group 1 and it's on the left side of a formula. So +1 times 3 equals +3 plus x, we don't know that yet, and then O is equal to -2 times 4, so -8. And we know this whole thing needs to equal 0. So if you start to combine like terms, you have x plus -5 equals 0. So add 5, x equals +5. So the phosphorus in this compound happens to equal a +5 charge. That's the oxidation number you'd expect. The PtCl6 anion. Now chlorine is in group 7, that's the more electronegative, so this is a different rule than what we've used up to this point. So the more electronegative is going to take the predicted charge, and so -1 because it's a group 7, so -1 times 6, and we know that this whole thing needs to add to -2, so x plus -6 equals -2, so add -6 to, or add 6 to both sides, x equals +4, so the platinum in this case would be a +4 ion. The arsenic in this acid, it can split. We know this whole thing needs to equal 0 because formulas always have to equal to 0. 3 times +1 gives you +3 plus x, whatever that happens to be, and then O is -2 times 3, so that gives you -6. So combine the like terms, x plus -3 equals 0. Add 3 to both sides. In this case, x is equal to +3, so arsenic is going to represent a +3 charge. And then we have the permanganate anion. We know it needs to sum to -1, so -8 because -2 times 4 is -8, plus a number, So add your 8, x is equal to plus 7. So the manganese must take a plus 7 charge in this compound. After watching this video, you should have a pretty good idea of how to determine the oxidation number of an atom inside of a compound. Notice that we use 3 rules most often. We used that O is almost always minus 2. We use that a compound has to sum to 0. We use that a polyatomic ion oxidation numbers need to add to the charge on that ion. The other rule that we used was that the most electronegative atom is going to take the predicted charge. And then for the binary compound, we were able to add those up to 0 as well. Hope that helps.